division. Remember, if you have 12, what was the easy one that I had yesterday? 27. 2,796 divided by 12. If I'm going to use long division, remember, you're asking yourself these questions of how many times does 12 go into 2? Or does how many times does 12 go into 27? 27. How many times does 2 or 12 go into 27? Multiply in. And then what did you do? You get 3, you pull down the 9, and you get 3. Okay. 36. 6. Hey, look at that. We have a nice, easy one. I'm showing you, I'm trying to remind you guys of how this works. What you're doing here is you're trying to figure out how many times does 12 go into 27. It goes in twice. 2 times 12 is 24. What's left over is 3. You bring down the next column. 12 goes into 39. 3 times 12 is 36. Subtract them, 3, you just continue going on. You're starting with, you're trying to figure out, you're working your way from the highest power, or the highest digit, yeah, thank you, you're working your way backwards. Instead of starting at the beginning, working your way forwards like with multiplication. So what we're doing here today, though, instead of dividing out like this, we're going to be dividing out stuff like this. And I wanted to show you guys that same basic idea of what it started to look like. Remember when we did synthetic division a week ago? We always used the coefficients. We put them in descending order. We always had zeros for placeholders. Well, we keep all of our variables with our coefficients in this case, and we still put zeros in for placeholders if we need them. So I would start out by this. This would be 2x cubed minus 7x squared minus 17x minus 3 divided by 2x plus 3. Now, it follows the same general idea of numerical long division, but I ask the questions a little bit differently. For example, what I'm trying to do here every time I use long division is I'm trying to eliminate each consecutive power. I'm going to try and eliminate the x cubed, then I'm going to try and eliminate x squared, then I'm going to try and eliminate the x value, and so on, until I run out of space. So I'm going to ask myself this kind of a reoccurring question. How do I turn a 2x into a 2x cubed? What do I have to multiply it by? X squared, good. So I have to multiply it by an x squared. Where do I put the x squared, do you think? Above the x cubed, x squared, x, or the 3? Above the x squared. Whenever you start these problems, whatever degree you have to multiply by, you put that above whatever it is underneath the divider symbol. Okay? Now, just like we did earlier, I took that, 12 went to 27 twice, so we multiplied the 2 over. Multiply it over here. I get 2x cubed plus 3x squared. And just like you did in long division, you subtract it out. So I subtract these. 2x cubed minus 2x cubed is 0. Negative 7 minus 3 is how much? Negative 10, good. And now I bring down the next term. And I start again with the same question. How do I turn a 2x into a negative 10x squared? Very good. I want to multiply it by a negative 5x. Multiply that in again over here. So we have negative 10x squared minus 15x. Yeah? Okay. Once I distribute that negative 5 back over to the 2x plus 3, I've written that back down. And now again, I subtract these two terms. Negative 10 minus negative 10 is 0. It's gone. Negative 17 minus negative 15 is how much? Negative 2. Good. So it's negative 2x. And I bring down the negative 3. Good. Yeah, pretty much. Pretty much. And now, again, to turn the 2x into a negative 2x, I multiply by what again, Dylan? Negative 1. Yes, sir?
When it's out of order, like it doesn't 2x to the 4th, like you said, 7x to the second, you gotta add that.
That placeholder? Yeah. Always put placeholders in. For long division and for synthetic, which we'll be doing again here in a little bit. Again, now I multiply everything by the negative 1. I have negative 2x minus 3. Subtract it out, and I have no remainder. So that's it. So when I divide 2x cubed minus 7x squared minus 17x minus 3 by 2x plus 3, my answer is x squared minus 5x minus 1. And like I said, this process is going to allow us to find slant asymptotes later on. Just introducing it a little bit today, and then we're going to go back to it again later. Yeah?
What would happen if you put 2x plus 3 inside of that equation, the bigger one?
You can't do it. You can't do it. Yes, ma'am?
If we in the first one, if we like split that up, then could we do it in the way that we did on Friday?
Oh, by factoring?
Yeah. Well, was that
It's-
you like boiled it and then you distributed it?
Yeah, it's, what you're thinking about is going through a little factoring stuff. Not necessarily. There will be a little bit similar to that here in a little while, but not yet.
So like you couldn't solve that equation by those ways.
Yes and no. Yes and no. I could show you the other way synthetically here, and it does work, but it's messier because you'll have a fraction to work with. All right. Again, the process works the same. You're trying to eliminate that first term each time. Let's try one more of these, and we'll stop with that. I have 2x to the 4th, a plus 3x cubed, plus 5x, minus 1. Am I missing anything in that sequence?
Square.
What am I missing? The square term. What do I have to put in place of it? Good. So when I start the problem out, as I'm writing my stuff out in that descending order, if I notice that I'm missing a term, automatically put in a 0x squared or 0 whatever power, or even a 0 for your constant if you need to put that in order so you don't miss something. And again, this looks like it's going to be awful, but you're going to ask yourself the same question. How do I turn an x squared into a 2x to the 4th? 2x squared. So where do I put that then? What above what value?
0x squared.
Perfect. I put that right above here, 2x squared. Now what do you think I have to do? Yeah, multiply those all together. So you have 2x to the 4th. Remember, I'm multiplying back over here. Minus 4x cubed plus 4x squared. 3 simple subtraction problems. 2 minus 2, gone. 3 minus negative 4 is 7x cubed, good. And now what's my next step to do? Drop down the next one. And drop down the next. What question are you going to ask yourself now? Okay. Okay. What's the next highest exponent you see? Right.
In the bottom?
Yeah. Okay. How do I turn an x squared into a 7x cubed? What do you multiply by? 7x. Distribute across again. then subtract. Seven x cubes drop out. Hopefully they don't. You did something wrong. -4 minus -14. And then 5 minus 14 is -9. And then bring down the negative. And then lastly, how do I turn an x squared into a 10x squared? I multiply by 10. Good. And I'm running out of space. We didn't wind up with 0 this time, did we? Do you remember when you divide before? You put that back up as its remainder, right? Do you remember what remainders really were? They were fractions. They were fractional amounts. We're not going to be creating the decimals here because that just gets horrible. So what we're going to do is that this is a fractional amount. So your answer to all of this messiness would be 2x squared plus 7x plus 10. Now, 11x, is it positive or negative? Positive, so I write plus 11x minus 21 over, what do we divide by? And that's your remainder. If you were doing regular old boring long division, what's that? No. So if we were doing regular old boring long division, 13 divided by 2, well, take 6, subtract out, you're left with 1. So it would be, your answer would be 6 and a half. Yeah?
Why are you adding the -9x and the 20x?
-9 minus -20.
Oh, I thought it was...
I did the same change opposite. Right?
Oh, okay. I didn't know.
So I'm writing it out as, whenever I have a remainder then, I just write it as a fractional amount. And that's my solution. Okay? Like I said, this is going to come back into play later on in the school year. I just felt this was a good spot. Might as well introduce it because we're going to smell the difference today. Okay? So let's switch back again into good old-fashioned synthetic. When we did synthetic division the other day, they were telling you to use synthetic division to find a solution by synthetic substitution. That's what they were calling it. Today we're going to start to introduce you guys into factoring via synthetic division. What we're going to be working on in this case is that they're going to be giving you a couple of different terms. They might be giving you, in this case, they're giving you a term, x minus 2. If x minus 2 is your term, what is your 0? 2. When you're using synthetic division, you always divide by whatever that 0 is. So in this case, they're giving you the term, x minus 2, which means you have to come up with the 0. In other problems here in a minute, they're going to give you a 0, so you just use that value. You just have to read it carefully. Now, man, what you were asking about earlier, that 2x plus 3, that part was the term. If I wanted to use synthetic division with that, my 0 would have been -3/2. Okay? So I could have used synthetic division with -3/2 and worked through that, but I'm going to have fractions all through that synthetic, and that kind of defeats the purpose of making synthetic division easy.
Yeah.
Okay? So it would have worked, would have been a big deal, it just would have been mess. Remember the rules again for synthetic division. You're plucking out all of your coefficients and putting placeholders of 0 if needed. So synthetically divided, I have a 1, 2, -6, -9. And I'm going to divide it by x minus 2, which means the number on the outside, is it going to be a -2 or is it going to be a +2? It's going to be positive. Because if this is my term, if x minus 2 is my term, the 0 for that is positive 2. What was your first step for synthetic division? Drop the 1. Now what? Yep, 2 times 1 gives me 2. What do you do with that? Add them. 2 times 4 is? 8 and negative 6 is? 2 times 2 is? Negative 9 and 4 is? Okay. Now, all you have right here are coefficients. We need to figure out what their exponents are going to be. So here's what happens. Every time you use synthetic division, you're dropping your problem 1 degree. If I started out with an x cubed, what is this now here? This is an x squared. What's the 4th? The 2 would be the constant, and the negative 5 would be considered the the leftover. What's the leftover? The remainder. So as you're going through this now, when I divided all this junk by x minus 2, I used the 0 of it. It now gives me an answer of x squared plus 4x plus 2 minus 5 over x minus 2. Because I always put that as the fractional amount. Whatever my divisor, I don't know what word it is, whatever is the term you're trying to divide by, that's what goes in the bottom fraction. Yes, ma'am?
So do you only use the remainder of that over x minus 2? Or usually is that the whole thing?
It's just the remainder that's over x minus 2. Yeah, and not always are you going to have a remainder. Sometimes you're going to have that equals 0 at the end. Okay? Yeah?
So it's the same thing you do with synthetic multiplication, but you do that on last step.
Yeah, you just do that last. I mean, it's always synthetic division, but yes, it's the same thing. What we were doing is synthetic substitution. So it was just the same process, but it meant something different at the end. But yeah, this is the only thing. So if I'm synthetically dividing, I wind up with that. Let's do the same thing and use x plus 3 with the same values. If I use x plus 3, what's my 0? It's okay. I know, great. Well, you're in here for some reason. So I use synthetic division again with a different 0. They gave me a term of x plus 3, so that means the 0 would be just negative 3. Again, drop the 1, multiply, add, multiply, add, multiply, add. Is there a remainder in this problem? What is your answer then? And that's your answer. Okay? Synthetic division is pretty awesome. It's real quick, it's real painless. There's not a lot going on here. Okay? The other really nice thing about synthetic division is that it's going to allow us to find factoring and zeros. If you can factor using synthetic division, that means you're also going to be able to find your zeros. Remember, the difference between factoring and finding zeros is what? It's the only difference between those two problems. Getting an answer. Okay, what is shown in those problems that tells you to get an answer? Equal sign. Okay. So let's look at this. Let's try that. Let's try factoring knowing that I have a 0. In this problem here, do you see how it says f of negative 3 is 0? That means that negative 3 is the 0. What's that? No, what this means is that if f of negative 3 is your 0, that means the term would be what? X plus 3. Yeah, you're using -3 for your synthetic thing, okay? Remember, the difference between this problem, the one we just did, is that the problem we did gave you the term. This one's giving you the 0. And since when we use synthetic division, we always use the 0, I don't have to do anything. I just start with my -3 out front. Coefficients, do I need to worry about any placeholders in this one? No. So we're factoring this using synthetic. Drop the 2, -6, add, -15, add, -9, and add.
Can you use this? Yeah,
It's kind of.
I like this.
So now we have 2x squared plus 5x plus 3. And what was our other term that we're using right now? If my 0 was -3, what was my other term? X plus. So right now, we have taken this four-termed one, and we have already broken it down into a trinomial and a binomial. Yeah. Remember at the very beginning, we had that 0 was -3? If I had a 0 at -3, then my term is x plus 3.
Oh, okay.
All right, so I'm just bringing that down here in a minute, because when we factor, we want to write out in factored form. So I look at this where we're at. What's 2 times 3?
Like 2.
What times what 6 you add together to get 5?
2
2 and 3. So you factor this last part by grouping. Again, GCFs. 3. Remember this x plus 3 is up here too. So your fully factored form, 2x plus 3, x plus 1, and x plus 3. So given one of the zeros of the function, you're able to factor real fast. Okay? It's at least breaking it down into a smaller problem. Instead of those large 4-term problems we had earlier, it's at least getting it down into a trinomial, which for most of us is a lot easier to work with. Okay? Yeah.
Why didn't you the one before we had x squared plus 4x plus 2, so we had x minus 2.
Because I couldn't factor that in. Because I had it right here. There was nothing left for me to do. Let's try another one. Again, 1 0 of that function is x equals 2. So it says the 0 is 2. If the 0 is 2, what's the term? Good. If 0 is 2, that means the term was x minus 2. Now it wants us to find all of the other zeros, which means we're going to factor it fully and then set them equal to 0. We do the exact same process. Okay? I'm using synthetic division. I know it told me in the problem 1 0 of x cubed minus 2x minus 9x plus 18 is 2. That 2 goes out on the outside. Do I need to worry about any of my coefficients? Do I have to worry about any placeholders? Synthetically divide. Drop the 1. I had no remainder, did I? So when I use synthetic division there, what is my new term? and this came from up here. Could you look at that from that spot right there and tell me my zeros? Yeah, good. So from here, I was able to factor it out to become x squared minus 9. So I have plus or minus 3, and 2 are all the zeros of that function. If I'm given one of the zeros, I use synthetic division. It'll bring down the degree, make the factoring easier, and I can find the other zeros right from there. You guys are all looking at it like you're waiting for like a shoe to drop here, like a curveball or something. What do you got?
Wait, so what happened to the x that you factored out when the x squared was done? Wouldn't it be x cubed plus minus?
No. Every time you, after you synthetically divide, this starts as a cube and it ends in a square.
Alright.
Okay, because you're going down a degree. Every time you use synthetic division, you go down a degree. Yeah. Remember, they're giving you the 0 up top. It tells you your 0 is 2. So if the 0 of that is 2, that means the term was x minus 2. Well, if you're finding the zeros or you're factoring, you still write it out the same way. The only difference between finding zeros and factoring is this very last step here. You would still factor out everything like you would normally. Oh, if you're factoring. Well, if you're factoring, you just bring it down and put it in your answer because it was a factor of it, that's all.
Are they all gonna like end up with 2 zeros here, like all of them?
Maybe, maybe not. Let's try this one. I have x cubed minus 8x squared plus 4x squared plus 48, and a 0 is at 4. So if I have a 0 at 4, what's my term? X minus 4. Okay, good. So we start by remembering that. If my 0 is at 4, my term is x minus 4. I'm writing that down up at top, so I remember to put it in there later. Okay? Again, you know your 0 is 4, so that goes on the outside of your synthetic division. And on the inside of the synthetic division, you pluck out all of your coefficients. Do I need to worry about any placeholders again here? I know you guys are working diligently here. I'll give you a second to see how you come up with it. That's the sign.
I probably had to put that negative 12 by 48, so I stopped and waited.
Right now, we have factored it out to be x squared minus 4x minus 12. 1 times what's negative 12? You add together to get negative 4.
Negative 6 and 2.
Negative 6 and 2, yeah. So it's x minus 6, x plus 2. Our term from earlier was x minus 4, which means, what are the 3 zeros of the function? And yeah, Maddie, eventually we'll have imaginary numbers and all that stuff too. I don't think we do that today, but we'll get there. Tomorrow, actually. And Thursday. Texas is next Tuesday, yeah. No, the test will be next Tuesday on this. What's that?
That's a little scary.
Well, this is the first time you've seen this synthetic division. And for the next, basically 6, 5, 6, 6, and 6, 7, all do the same thing. It's just little tweaks of it, all right? Take a second here, and let's finish up with this last one. Find all the rest of the zeros given this. You're given that 10 is a zero of the function. Go ahead and find all the rest of the zeros. So if 10 is my 0, that meant my term would have been x minus 10. So I'm just going to leave that over here for right now. So remember to put that in. Drop 2. Now I have 2x squared plus 6x plus 4 and an x minus 10 all equals 0.
If you look at it, it's like long division, but backwards and upside down.
Yes. What's the first rule of factoring? What did you say? GCF. Now, 6x squared, or excuse me, 2x squared, 6x, and a 4, there's a GCF of 2. If I take a 2 out, then I have x squared plus 3x plus 2, and then x minus 10. Since I'm finding zeros, does this 2 out here matter? Nope. What times what's 2? You add together to get 3. 2 and 1. Your zeros are? You get the same answer. Uh-oh. Yeah, you should get the same answer. The only thing is, if you do that, you had to split middle term, and you got a little bit more. You can get a little messy where you can make an error here or there. Okay. So remember, when you're doing these problems tonight, read carefully whether or not they're giving you a 0 or they're giving you the term. Okay. Just so you can see where you messed up.
I know.
Okay.
I just.
So I didn't
Oh.
To the left.